Hey everyone. So in this chapter, we are going to find trailing zeros in n factorial. So what this question could mean is basically we would be given a number n. Just take an example of 5. So how many zeros are there at the end of 5 factorial? So 5 factorial is equals to 120. So the number of trailing zeros that are there in 5 factorial is 1. Same ways, if you want to go for 10 factorial, it comes out to be 10 into 9 into 8 into 7 till 1. Now, how many trailing zeros would be there? You can calculate it. This will come out to be 36, 28, 800. So, 2 trailing zeros. This is what you have to calculate in this question. Okay, so let us see first of all how is a zero produced. So a 10 or a 0 basically comes in when you multiply a 2 and a 5. Basically a pair of 2 and a 5 gives you 1 0 at the end, right? So if you see 50 is 5 into 5 into 2. How many pairs of 2 and 5? Only one pair of 2 and 5. That's why one trailing zero. Let's see it 20. This is 5 into 2 into 2. How many pairs? Again, only one pair of 5 and 2. That's why 1 0. But if you go for 100, this is 5 into 5, 2 into 2. How many pairs of 2 and 5? Two pairs of 2 and 5. That is why two trailing zeros. So I hope you would have understood that if there is n factorial and we need to calculate the number of trailing zeros, if we calculate the pairs of 2 and 5, our job would be done, right? So let's see this. 5 factorial. This is 5 into 4 into 3 into 2 into 1. If we see 4, this could be written as 2 into 2. How many total pairs of 5 and 2? One pair. That is why if you calculate this 5 factorial, it comes out to be 120. And there is one pair of 0. Let's go for 10 factorial. 10 into 9 into 8 into 7 into 6 into 5 into 1. Let's break down all of it. This is 3 into 3. This is 2 into 5. This is 2 into 2 into 2. This is 2 into 3. 2 into 2. Yeah. How many pair of 2s and 5? One pair. And another one is this 5. This could be taken. Rest of the 2s are in abundance, but they do not bring a 0 alone. That is why two trailing zeros. So now, if did you notice something? Whenever you're going to do something for n factorial, 2s are always going to be in abundance, right? 2s are always going to be in abundance. So if we calculate the number of 5s, only the number of 5s, our job would be done. Yes or no? Our job would be done, right? So let us see it for 15 factorial. Okay, this is 15 into 14 till 2 into 1. How many factors of 5 are there? How many multiples of 5 are there? One is going to be 5, another one is going to be 10, and next one is going to be 15. Basically, if I would have done 15 by 5, it would have given me 3, right? Same ways, if I say 17 factorial, how many multiples of 5 are there in this? 7 by 5, which is going to be again 3, and you know it, 5, 10, and 15. All these three numbers are multiples of 5 and they are only going to produce zeros because 2's are in abundance already, right? So can I say that number of trailing zeros in n factorial equals to n by 5? Can I say that? Let's see. Let's do it for 30 factorial. How many zeros? 30 by 5. This is going to be 6. Let's see how many are multiples of 5 here. One is going to be 5, one is going to be 10, 15, 20, 25, 30. This gives me 1 5, this gives me 1 5, this gives me 1 5. This also gives me 1 5. This is 5 into 5. This also is 5 into 6. Basically 5 into 2 into 3. So 1 5 2 5 3 5 4 5 5 5 6 5 7 5. Answer is going to be 7 and not 6. Why? If you see 25 is not going to give us 1 5. It is going to give us 2 5s. 5 into 5. Right? Let's do it for 50 factorial also. So 50 by 5, you're considering answer as 10. Now let's see the multiples of 5 in this. 5 would be there, 10 would be there, 15 would be there, 20 would be there, 25 would be there, 30, 35, 40, 45, and 50. Now 1 5, 1 5, 1 5, 1 5. This is 5 into 5. This again is going to give me 1 5. This is going to give me 1 5. This again is going to give me 1 5. 1 5. This is 5 into 5 into 2. So again 2 5s. So don't you think multiples of 25 are going to give me 1 5 extra? Yes or no, right? You can do the same thing for 75 factorial or 76 factorial also, right? So can I generalize it by saying number of trailing zeros in n factorial is n by 5 plus n by 25, which is what? Which is basically 5 square. Let's see it for 130 factorial. For 130 factorial, there's going to come as 125, which is what? 5 into 5 into 5. Again 1 5 extra. So if you would have noticed, now you can't generalize it like this. You have to be like n divided by 5 cube. Basically all the factors of 5 cube, all the multiples of 5 cube, sorry, is going to give you 1 5 extra. Then all the multiples of 5 raised to the power 4 is going to give you 1 5 extra, right? So this is going to go on like this, and this is going to be your formula for calculating the trailing zeros in n factorial. I hope you would have got it. So just you could be questioning, where would this loop end? Where would this loop end? Just see this. Just see this. When your denominator is greater than numerator, in that case, of course, every value after this is going to be 0, right? For example, if I say, tell me the number of trailing zeros in 7 factorial, 700 factorial. So what you did, 700 divided by 5 plus 700 divided by 25, great, plus 700 divided by 125 plus 700 divided by 625 plus 700 divided by 5 raised to the power 5, which is definitely going to be bigger than 700. So this value turns out to be 0, and all the values ahead are going to be 0. Yes or no? So we have to calculate till here, right? So what we can do is, let's write pseudocode for this. Let us say you're given a number n. You can initialize your denominator to 0 or to 5, sorry, to 5, and initialize your answer to 0, right? What you have to do is you have to keep on fetching out zeros out of this number n. So while your denominator is lesser than equals to n, see it here, while my denominator is lesser than equals to n, till that point what you have to do is you have to keep on adding answer plus equals to n by denominator. And what you have to do is, now the denominator would be 5 square, then it would be 5 cube, right? So denominator multiplies equals to 5. That is all. And finally you need to return answer. This is a small piece of code for finding trailing zeros in n factorial, right? I'm pretty sure you would be able to code it now. I'm pretty sure about it. So rather than seeing me how I'm coding again, you should pause the video, try coding yourself, and then if you're stuck somewhere, you can then come back again, and then you can try coding it. Okay, let's move to the code. Okay, so here you're given n. What you have to do is you have to take answer as 0, and you have to take denominator equals 5. Just make sure that naming is always good, because in interviews we do make sure that we always have a look at the names. Okay, so while your denominator is lesser than equals to your n, okay, what we have to do is answer plus equals to n by denominator. Lastly, denominator, okay, and finally what we have to do is return answer. Okay, small piece of code. Let's try running it up. Okay, let's see, where is it stuck. Oh, I think I gave a wrong spelling, denominator. Yeah. And yeah, what happens is, generally when you take something with a bigger name, spelling mistakes could be there. So please make sure that either you are taking a small name, but it should be meaningful. Okay. Okay, great. All the 3 test cases have passed. Let's submit it. Perfect. All the test cases ran and we are good. So I hope you would have understood this question. If you have not, try going over the video again. And if you have, move to the next question. I'll see you again. See you. Bye-bye.